Hello, in this video I will be going through the answer to question 8.4 from November 2021, paper 1. A student emailed me asking me to explain the answer because even while looking at the mark scheme, they still didn't understand how to get to the correct answer. Whenever you're looking at a question like this one where you have to use an electrochemical series to construct a complete equation, you have to follow a basic set of rules. Rule number one, when you combine two half equations, one is going forward and one is going backwards. And rule number 2, the half equation with a more positive E0 value will go forward and the one with a more negative E0 value will go backwards. In this case, we are looking at the half equation here and are expected to work out which half equation we want to pair it with. We are told in the question we have to use iron, so the obvious half equation to use is this one. If you don't think any more closely than that, you end up combining the two half equations to give you this. However, this is not the correct answer, because there is a third rule you have to follow. Rule 3 is that anything that can react will react. More specifically, we need to check whether the products of either half equation will react with the reactants or products from the other half equation. In this case, the half equation for the iron produces iron 2+. However, iron 2+ will react with VO2+, which you can see because you can compare the E0 values of these two half equations. The VO2 plus half equation has an E0 value of +1, whereas the iron 2+ to iron 3+ half equation has an E0 value of 0.77, and therefore the VO2 plus half equation can be reduced, and the iron 2+ can be oxidized to iron 3+. Therefore, VO2 plus will oxidize iron all the way from iron element to iron 3+. What that means is that we have to combine these two half equations, and then we have to combine it with the VO2 plus half equation in the normal way. So let's combine the two iron half equations first, and then combine that with the VO2 equation as normal, giving us that as our final equation.